In the first system, this is the first thing we gave UC Davis. I was so worried. We were 6 weeks from harvest. And my engineers told me, oh, we don't know if we can get it done. And I said, which is really great, because they usually have some excuse why things are going to be late. So I said, great. I said, you call up the chairman of the department, UC Davis, his name is David Block, and you tell him to slow down harvest. The grapes will not be harvested on September 15th. You tell him to push it back 3 weeks because your firmware is late. You go right ahead and do that. And all of a sudden I drilled in their heads, there are deadlines that are real. They don't get changed. You can talk all you want, but they don't get fixed. So we decided, for risk point of view, we'd make the temperature controller one box. We'd make the Brix meter, which I'll explain in a minute, another box, and the pump over system, another box. So if we failed, we still could give 2 out of the 3, or 1 out of the 3 to Davis. So this is our Brix meter. It's an electromechanical instrument. It fits in through a custom-made cap. In this fermenter, all of the instruments fit in through the top. There's no connection to the fermenter except through this cap, and then you can customize the cap for experiments. So here's the Brix meter. There's electronics and a shield to prevent spraying getting on the electronics. I'll talk about that in a minute. Here's the sensor. Can you see the little pipe inside? So the sensor is a couple of stainless steel tubes, and there's one down there. And what you do is you blow air down that tube, and it bubbles out. Then it comes up into the larger tube, and it comes out of these side holes. Okay? So the pressure in the bottom tube is whatever pressure is required to push air out of a tube that long, and the pressure in the big tube is whatever pressure is required to push air out of a tube there. Therefore, you're in effect creating 2 pressures 7.5 inches apart. And that differential pressure doesn't matter where you are, so it's a common mode rejection that engineers know a lot about. Wine guys don't know anything about. Okay, so if I can measure the pressure of those 2 things, I know what the pressure ought to be. It ought to be 7.5 inches of water. Sometimes pressure is measured in inches of water. And if it isn't, then I can say the liquid in there is not water, it's something else, and I can measure the density. So there's the board. Fits inside a 2-inch stainless steel pipe. There's the air pump right there. You go down to Walgreens and you get yourself a blood pressure kit for your arm. Tear it apart. You know it's going to be cheap and you know it's going to be reliable because it's from Walgreens, right? And there's the pump. And the pump pumps air, pumps through this pipe, pumps down to the bottom. Air comes back up, comes out of there. So this tube measures the pressure in the big pipe. This tube measures the pressure in the long vertical pipe, and the 2 pressures come to this thing, and this is a membrane-based, a MEMS-based pressure meter. This measures 10 inches of water full scale. So this pressure meter will measure 10 inches full scale with 4096 bits of accuracy. So right now, I turn on the air, and I bubble through here, and this thing measures pressure. Okay? Mother Peacock, and there's only one in here. It's kind of buried back here. And Mother Peacock says, okay, it's time to measure. Turn on the pressure, run the air. It turns out the bubbles are very noisy. It turns out you have to run something like 10,000 bubbles and average over 10,000 bubbles. So it gets a register and it starts counting how many bubbles came out and what the pressure difference was for every bubble. And it records all that and stores it in memory, and then it averages out. And then it makes 5 measurements like that. And then that's your answer. Now that answer is the differential in pressure of what should be 7.5 inches. Okay, if it's 8.25 inches, that's 10% higher. So then you take 8.75 divided by 7.5, that's 1.10 times more stuff. The thing says the specific gravity is 1.10, goes to a lookup table and calculates Brix, because there's a 1-to-1 relationship, almost a straight line between Brix. So then it tells you what Brix, and it reads out the Brix on the little LCD here. Now the other thing this thing does is, that's a radio chip we make, and this is an antenna. So this thing also radios back to mom. So by having this thing in every fermenter, you have an RF connection to every fermenter, and you can simultaneously, there's a thermistor down here as well, here. So you're measuring in the tank temperature and Brix. These are the 2 most important measurements. You can make wine for your whole life if you only know those 2 things. That's why this one is an RF board and talks back home. Again, this is one PSOC. Actually, this pressure sensor costs 2 or 3 times more than the entire board. The other chips are almost free.